Friends, this question from 25th February 2024 quiz 1 software testing ST question paper. So there is a control flow graph given in the question. CFZ is given in the question. It consists of 6 nodes, right? Total nodes 1 to 6, and 1 is the initial node and F is the final node, that is final vertex. Sorry, 6th node, 6 is the final vertex. It is double circle. And in the question, find the number of test requirements for the prime path coverage. That is, they are asking number of test paths required for the prime path coverage, PPC. For the prime path coverage, how many test paths required? The prime path are maximal length of simple path. Maximal length of simple paths. So the simple paths are no repeated nodes except starting node and the final node. The simple path contains a list of nodes. It contains a list of nodes. It consists of the starting node and the final node. No nodes are repeated in between. This is the simple path. So prime path is a maximum length of the simple path. It cannot be extended. After that, simple path cannot be extended. So maximum length of, if for example 1 is a simple path, it is the maximum length, it cannot be extended. So this is the prime path. So how to find this prime path coverage? Prime path coverage means it consists of the number of, it covers all the prime paths, right? Prime path is, it covers all prime paths in the control flow graph present in the CFG, which in the control flow graph, how many prime paths are there? All the prime paths are covered by the prime path coverage. So for this prime path coverage, how many test paths are required? They are asking find the number of test paths. For this, we want to find the simple paths. First we find the simple paths of length starting from 0, 1, 2 and so on up to possible length. You have to find after maximum length of simple paths are the prime paths. Okay, so first we want to find the length of simple paths of length 0. So length 0 simple paths. Length 0 means they are nodes, right? Simply nodes. That is, write all the nodes. Node 1, node 2, node 3, node 4, node 5 and node 6. Length 0 of simple paths. So node 6 is a terminal node. It ends with exclamation mark. Exclamation mark means it cannot be extended. So it cannot be extended. So with exclamation mark is it ends with the path that ends with the terminal node 6. Okay, the path which ends with the terminal node is represented with ends with this mark, exclamation mark. Okay, length 1 simple paths. That is, we extend the length 1 simple path of 1 to, so that is next node. So starting from 1 to 2 is a simple path of length 1. 1 to 2 is a simple path of length 1. Is it possible to extend another from node 1? Yes, node 1 to 6. 1 to 6 is also a simple path of length 1. And it is ends with node final vertex, right? That is exclamation mark. So node 1 only 2 are possible. This one and this one. Next, for starting with node 2. The length of the simple paths is 1 starting at node 2. Here starting at node 2, or that is, we extend 2 to 3, right? This one 2 to 3. Next we extend 2 to 5, right? 2 to 5. We started with 1 and go to 1 by 1. Okay, that is easy, otherwise we are confused. 2 to 3, 2 to 5. Is it possible to extend node to another node? No, it's not possible. So only 2 are possible, 2 to 5 and 2 to 3. Next, starting from node 3, that is, we extend the length this length 0 to length 1 by next node. So 3 to 5 is possible, right? 3 to 5 is possible. Another node is also possible, 3 to 4, this node 3 to 4. Another path, node, another path is also possible. So there are only 2 paths are possible from node 3. Next, starting at node 4, so that extend node 4 of length 0 to length 1, that is starting from node 4 to next node, that is 4 to 3. 4 to 3 is a simple path of length 1. Is it another nodes are possible? No, because only one edge from 4 to 3, only one path is possible. Next we extend node 5. Node 5, so here, so node 5 also only one edge, that is 5 to 6, because it ends with exclamation mark, right? Final vertex. Okay, node 5 to 6. Is there possible to 6 to? No other nodes are connected, because this is the final vertex, so there are no simple paths of length 1, not possible. Next we will go for length 2, that is length equals to 2, that is we extend length 1 to length 2 by next node. So next node, first we select node 1 to 2, this path, that is node 1 to 2. Is it possible to extend node 1 to 2 and 2 to 3 possible, right? 2 to 3, it becomes length 2. This is 1, this is 1, length becomes 2, right? Next 1 to 2 and 2 to 5 also possible, right? 2 to 5, that is 1 to 5 is also possible. So this is completed. So this is completed. This is extended to length 2. Okay, next 1 to 6, is it possible to extend 1 to 6? So no, not possible, because terminal node is 6, so it's not possible. There are other paths are not possible. Next we will select 2 to 3, this one, to extend the length 2 to 3, that is 2 to 3, is it possible to extend? So 3 to 5, right? 2 to this length 1, this length 1, length becomes 2. 2 to 3, 3 to 5. Next 2 to 3, 2 to 3 and 3 to 4 is also possible, right? 3 to 4. Next 2 to 3, only 2 to 3, 2 possible, no other possible. Next this is completed. Next 2 to 5, 2 to 5, is it possible to extend next node? 2 to 5, 6, right? We extend 1 2, length becomes 2. 2 to 5, 6. 2 to 5, no other nodes are possible, so no other paths are simple paths are possible for length 2. Next this is completed. Next go for node 3, this one, node 3. So we extend 3 to 5 of length 1 to next node, that is 3 5. Is it possible to extend 3 to 5? 5 to 6, right? 5 to 6, which is ends with exclamation mark, because the terminal node is there. Next 3 5, another is possible? No, not possible, only 3 5 6. Next 3 to 4, 3 4, is it possible? So 3 to 4 and 4 to 3 is possible, right? This is also a test path, simple path. Is it simple path? Yes, simple path, because starting node is 3, ending node is 3, so it is a valid simple path. No repeated nodes at the middle, only final and initial parts are allowed. This is a valid simple path. So these are also completed at node 3. Next we will select this one, 4 to 3. Is it possible to extend 4 to 3? 3 to 5, right? So that is 4 to 3, 3 to 5. 2 3, another path is possible. 4 2 3, and this is also possible, right? Length 1, length becomes 2, loops are allowed 4. It is a star because loops are represented with a star. 4 2 3 3 2 4 star. Okay, is it possible any other? No, not possible. Only length 2 only we are checking. Okay, next starting, it cannot be extended, right? 5 to 6 cannot be extended. No other nodes are there. There are no simple paths of length 2. So next, length equals to 3. That is, we extend the simple paths of length 2 to next node. If we add another node, it will become length 3, right? Okay. First we will extend 1 2 3. So that is 1 2 3. Is it possible to extend next node? 1 2 2 2 2 3. Okay, 3 to 4, right? Length 1 1 1. It becomes 3. 3 to 4. Is it possible? Next, 1 2 3 5 also possible, right? 1 2 3 5. So 1 2 3 and 5 also possible. Next, 1 2 3. Only 3 4 are possible. No other are possible. So this is completed. Next, 1 to 5. Extend 1 to 5 to next node. It will become length 3 simple path. So that is 1 to 5. Extend to 6, right? 1 2 5 6. This one. So this is the end node, exclamation mark. 1 2 5 6. Is it possible to extend any other node? 1 2 5. Only 6. After 5, only 6 is there. No other nodes are connected. So it's not possible to connect to next node. So these are completed. Next we will go to this list. 2 3 5. That is 2 3 5. 2 2 3 3 to 5 and 5 to 6 also possible, right? 5 to 6. Is it any other nodes? 2 to 3 3 to 5. Only this one is possible. 2 3 5 completed. Next 2 3 4. 2 3 4. Extend this one. 2 to 3 3 to 4 4 to 3. 4 to 3 is not a simple path because 3 is repeated at the middle. So it's not a simple path. It's not a simple path. So that is 2 to 3 3 to 4. It's not possible with 2 3 4 simple path. No other paths are possible. Next 2 5 6 we cannot extend. 2 5 6 we cannot extend. So 2 is completed. Only one path with starting with 2. Next 3. Next we will check for 3. No other paths. For 3 5 6. So for 3 5 6 we cannot extend, right? It is the final vertex. So 3 5 6 is not possible. 3 4 3. This is a loop, cannot be extended. 3 4 3. Again 3 repeated. So not possible. This with 3, no simple paths of length 3 are possible. Next 4 3 5. We extend this one. 4 3 5. That is 4 to 3 3 to 5 5 to 6, right? 5 to 6. It is also ends with exclamation mark because of final vertex. Is there any other possible? No, not possible. This is only with 4. 4 3 4 4 3 4 4 3 4, right? So 4 3 4 4 3 4. Next 5. So it's not a simple path, right? It's 4 is repeated here, not at the final and initial vertex. So it's not a simple path. So no other simple paths are possible with 4. So all are completed with length 3. Next we will go for length 4. We extend this one. First 1 2 3 4 2. So that is 1 2 3 4, we extend this length 3 to next node, it will become length 4, right? So first we extend the simple path 1 2 3 4, that is 1 2 2, 2 2 3, 3 2 4. We cannot extend, right? We cannot extend because 4 is so 1 2 2, 2 2 3, 3 2 4, 4 2 3, 3 is repeated, right? So it's not possible. It's not possible. So 1 2 3 5, we will check with 1 2 1 2 3 5, 1 2 2, 2 2 3, 3 2 5, 3 2 5, this one, not this one. 1 2 2, 2 2 3 2 5, 5 2 6 is there, right? 5 2 6 is possible. This 1 length 1 1 1, 4 length becomes 4, right? 1 1 1 1, if we add all the length it will become length 4. Is this possible? Is there any other paths are possible with 1 2 3 5, 1 2 3 5 6? No, not other possible. This cannot be extended, right? 1 2 5 6, 1 2 5 6 cannot be extended. After 6 no nodes are possible. So this one 2 3 5 6, for this 1 2 3 5 6 it cannot be extended because at the final vertex we cannot extend. 4 3 5 6, so that is 4 3 5 6 we cannot extend. So up to only length 4, only one simple path is there. So now we calculated all the simple paths of length 0, length 1, length 2, length 3 and length 4, and up to length 4 only. Length 5 is not possible because no other lengths are possible, no other simple paths are possible, up to length 4 only. Okay, now we want to find the prime paths or maximum length of the simple paths. Prime paths are all the simple paths of maximum length, right? So first we will go from backwards. Length 4 simple prime path. First prime path of length 4, 1 2 3 5 6, and this is ends with final vertex 6. This is the first prime path and this cannot be extended. So next length 3, we will go for reverse order. Length 3, so in the length 3 1 2 3 4 is covered. In the length 4 simple path no, right? 1 2 3 5 6, so 1 2 3 4 is a prime path. 1 2 3 4, this one is a prime path. Next 1 2 3 5, this one length 3 simple paths we are checking. So 1 2 3 5 here, right? 1 2 3 5 is there, so it's not a prime path. Next 1 2 5 6 is a prime path, is covered, so it's not covered, right? 1 2 3 5 6, so 1 2 2 5 6 is a prime path. So number 3 prime path is 1 2 5 6, exclamation mark, it ends with the final vertex 6 and it is a prime path of length 3. It is not covered in length 4 prime path. So next one is 2 3 5 6, 2 3 5 6 here, right? Up to this one, this is covered, so it's not a prime path. Next 4 3 5 6, so 4 3 5 6 is not covered anywhere, so this is the prime path. So prime path 4 of length 3, this length 3 equals to 4 3 and 5 and 6. These are prime paths of length 3. So these are also completed. This is completed. Next we will go to the length 2 prime path. Next one is 5. So first one is 1 2 3 is covered anywhere. So 1 2 3 is here, right? 1 2 3, so it's not a prime path. 1 2 5, 125 is here, right? 125, it's not a prime path. Next to 235. So 235 here, right? 235, it's not a prime path. 234. So 234 here, right? Length 3, second prime path. So it's not a prime path. Next 256. So 256 here, right? So it's not a prime path. So 356. Next one is 356. 356 is last prime path. Number 4 prime path is covered. 356 is not a 343 is not covered anywhere. 343. So 343 is a prime path and it is a loop and it cannot be extended. So this is a prime path of length 2. Next 435. So 435 is here, right? Up to here. 435. So it's not a prime path. Why we are checking? Because maximal length of simple paths are prime paths. So we are checking maximum length of simple paths. Okay. Next 434. 434 is not covered anywhere. It is a prime path and it is a loop also. So number 6 is 434. This is also a loop. There are 5 prime paths, 6 prime paths of length 2. Next we go for length 1. So length 1 2 is covered anywhere. So here, right? 1 2, so many prime paths. So 1 2 is not a prime path. Next 1 6. 1 6, this one. 1 6 is anywhere. So it's not covered in the prime paths. So 1 6 exclamation mark is a prime path. So is a prime path. 2 3. Next one is started with 2. 2 3 is here, right? 2 3 is here. Here also it's not a prime path. 2 5 is here. So it's not a prime path. 3 5 is in the length 3. Fourth simple path is not a prime path. 3 4 is covered. It's not a prime path. 4 3. So 4 3 here so many ways. So it's not a prime path. 5 6 is here, right? 5 6. So it's not a prime path. So these are length 0 are covered in almost all simple paths. So prime paths. So these are not prime paths. So number of prime paths are 7. So 7 equal to prime paths. And the number of test requirements for the prime path coverage. So prime path coverage for the prime path PPC. Prime path coverage means it covers all the prime paths, 7 prime paths in control flow graph. So number of prime paths to cover this we required 7 test requirements. So that is number of prime paths are 7. That is 7 prime paths. So answer for this question is 7. Of test paths, that is test paths given these test paths option A 1 B C D. A B C D there are set of test paths. So correct set of test paths for prime path coverage, that is it covers all the 7 prime paths. And prime paths, these are the 7. So prime paths. So this can be covered by the given option of the test paths. So which test paths, set of test paths covers all these prime paths. Okay. So 1 and 6 prime path, that is 7 is covered here. So write this one. Prime path number 7 means 1 to 6. So 1 to 6 covered here. And 1 to 5 6. 1 to 5 6 is this one, right? 3 is test path, prime path 3 is covered here. And here 1 2 3 4 is covered. So 2 is there. 2 is covered. Test path 2 is covered. This one is covered. So next 1 2 3 5 6. So this is not covered. Prime path 1, that is bigger one. 1 2 3 5 6 is not covered. So this is not covered. Because of this option A is incorrect. So next we will go to check the second option. So 1 to 6. So 7 is test prime paths. All these are 7 number, right? 1 to 6 is covered here. Next 1 to 3, 4 is covered. So prime path 2 is covered. So 1 to 5, 6 is not covered. So prime path 3 is not covered. So it's not covered. At least one prime path is not covered. It's not a prime path coverage, right? It's not considered as a prime path coverage. And the first one is also not covered. 1, 2, 3, 5, 6. So 1 is also not covered. Prime path 1 is not covered. So this option is incorrect. The prime path 7 is covered here. Next 1, 2, 5, 6. This one. Prime path 3 is covered here. Next 1, 2, 3, 5, 6. So this one. First one is covered here. Next 1, 2, 3, 4. So second is covered here. So up to this. And 4, 3, 5, 6 is also covered. 4 is also covered. 3, 3, 4, 3. So test path 5 is prime path 5 is also covered. This is also covered. This is covered. And 4, 3, 4 is not covered. This prime path is not covered by option C. So this is not the correct answer. So all these are the same options, similar options in D, but 4, 3, 4 is also there, right? Here 4, 3, 4. So 6 is covered. So this option D, it covers all the prime paths. So it considered as a prime path coverage. So the test paths 1, 6, 1, 2, 5, 6, 1, 2, 3, 5, 6, 1, 2, 3, 4, 3, 4, 3, 5, 6 covered all the 7 prime paths. So this is the answer for this question. Friends, if you like my videos, please like and subscribe my channel. And thank you for watching.